I want to thank my employer, CG Infinity. We are a consulting group and they are super supportive of employees doing stuff like this. In fact, they sponsor the Albuquerque .NET Users Group. So thank you, CG Infinity. And I want to thank the Salt Lake City .NET User Group for giving me this chance. I hope you get everything you're hoping for. So thank you guys so much. So what is Azure Service Bus? So here's a blurb, kind of a standard blurb. Azure Service Bus is Microsoft's cloud offering for developing message-based applications. So what the heck does that mean? And what is a message-based application? And we are going to be digging into all of that. But first, I want to call this out like a bus. What do we mean? What kind of bus are we talking about here? And if you've done any electronics, you're aware of what a bus is. A bus is usually a high speed, highly optimized, hardwired circuit that shuttles data between two components. I mean, think about the bus inside your computer that sits between the CPU and the memory. So when you look inside of Azure Service Bus, as we're going to do today, I don't see anything bus-like. It's not hard-coded. It's not bidirectional. It's not built for speed. That's really not its purpose. In fact, when we look inside of Azure Service Bus, what we're going to see is queues. It's all messaging. We send and receive messages, and they sit in queues. So I don't know why it's called Azure Service Bus. It has a lot more in common with things like RabbitMQ or the original MSMQ, Microsoft Message Queue, and in many ways similar to parts of Kafka. So I kind of feel like they should have just called it Azure Queues, and that would be a much clearer name. But they didn't ask me. So it's called Azure Service Bus, but I just think of it really as Azure Queues. So we're going to learn how to work with it. But before we do that, let me ask the question, like, what is a message-based architecture for? Why would we even want to complicate our lives and build one of these? So to address that question, I want to come at it from the perspective of, well, what's the opposite of a message-based architecture? So let's look at a standard sort of synchronous or tightly coupled kind of system. So let's say you're at work and you're feeling a little bit hungry. It happens to all of us. We get the munchies. So you walk out in the hallway and there's this vending machine, and you walk up to the vending machine, you put in some money, you make a selection, and your munchy crunchos pop out the bottom. And it's great. You're so happy because you got your munchy crunchos. So if we were to do a UML sequence diagram of that interaction, it might look something like this. You're the customer, there's the vending machine, you issued a command, make selection, and the command had some parameters. There was some money and a button you pushed, and then it returned a snack right away. You got your result, your munchy crunchos, or maybe you got 400 snack not found. I don't know, but you got a result back right away. So this is synchronous, tightly coupled. And even if you're using like a REST API, which uses messages because that's how the internet works, it's still synchronous. You still get either your 200 or your 400, and hopefully your snack from the server, from the vending machine server. So that is a normal, standard, tightly coupled system. Now, let's compare this to a messaging-based architecture. So now let's say you've been working a little more and you're really hungry. No joke now. You're hungry. And there's only one thing to do, and that's to head down, well, if you were here in Albuquerque, and that's to head down to Duran's Central Pharmacy. And if you're ever here at Albuquerque, let me know, and we'll go. This is a place you can't miss. I mean, I remember going here in the 1970s after elementary school with my mom. So you go to Duran's, and what do? Well, you go to the counter, you order your food, and the order is placed in a queue, right? Somebody fills out a little paper ticket and they stick it on one of those little spinny metal racks, and then it sits there. And then eventually, hopefully soon, somebody in the kitchen, a cook, grabs your order and they prepare it, and then your food comes out. So again, let's do this as a UML sequence diagram to really see what's going on here. So we've got the customer, the counter, the kitchen, and this is the key here, the order queue, which in the physical world is that actual spinny metal rack where the tickets get put. So what happens is when you place your order, it gets enqueued in the order queue. And then when the cook gets ready to cook it, they dequeue the order. They take the message off the system and then they prepare it and send it out. Now, there's actually a second queue in the restaurant, which is the delivery queue where they put the food up on a shelf under the warming lamps and ding a bell, but that just gets too complicated. So we're just going to stick with the one queue. So the key again is this order queue. And what it does is it decouples the front of the house from the back of the house. The order taking function and the food preparation function, the counter and the kitchen, are separated. They're decoupled. And that is the big win. So what does that get you? Well, a lot of things. So for example, the skills and equipment needed to kind of staff the front of the house is really different than the skills and equipment in the kitchen. So you can implement them separately, right? It completely separates the implementation of these two systems. And you can scale them separately. So let's say it's Sunday brunch, it's getting really busy, there's a line out the door. They might have 2 or 3 people at the counter and 5, 6, 7 cooks in the back. So they can scale these two systems separately. If it's a monolithic system, then you can't do that. So this is what kind of microservices is about. It's splitting up a system into components that have their own implementation logic and their own scale factor. And it's messages, a queue-based system that allows you to do that. So that's what it's for. That's the real world problem that this solves. And if you think about it, our world is full of systems like this. Like if you go on your favorite e-commerce app and you order some tennis shoes, there's a system that shows you the catalog. There's a system that manages your cart. The system that actually then takes the order and sends it and then picks it and packs it and ships it. And there's a ship tracking and there's an accounting function and there's email notifications. And those are all separate and they communicate via queues and messages. So the real world is filled with these, and we build software systems to model that. So just in case hadn't had dinner, I thought I would torture you and show you the blue corn enchiladas Christmas style, which means red and green chili, that you can get at Durant's. So now that you're hungry and want me to finish up, I'll keep going. So before we actually write code, now that we know why we're doing this, let's go ahead and do it. So we got to set up. We got to get our tooling, our environment, some prerequisites going. And this is Azure Service Bus, which means you're going to have to get on the Azure portal and set up some stuff. And the very first thing you need to set up on the Azure portal is a service bus namespace. So a service bus namespace is just a container. It will contain several queues. And it is kind of, it's 2 purposes. One is it's kind of the billing unit. So you get a bill and you can split up your bill by namespacing these things. And also it's kind of your security layer. Like you'll see in a second, we authenticate to the namespace before we get access to the queues and other entities. So you got to create a namespace. You can do it on the portal, click on through, or you can use, the Azure CLI like this. So here's a little CLI command to do namespace create, give it a resource group, give it a name, and give it a location. And after you do that, you will see on the Azure portal, your namespace has been created. So that's prerequisite 1. Make yourself a namespace. Then we have to make a queue. So again, you can do it drag drop, WYSIWYG on the portal, or you can use the CLI. And here's the command service bus queue create. specifying the resource group, your namespace, and the name of the queue. So you see it goes in your namespace. And after your queue is created, you can go look at it and you'll see it has no, oops, that was wrong. Let's go back, wrong click. It's active by default, and there are no messages, no dead letter messages, nothing scheduled, just a queue ready to use. So that's the second prerequisite. And then the third thing is in Visual Studio, you need to reference the azure.messaging.servicebus namespace. So you can use this command, install package, or however you like to install NuGet packages. And then in any code unit where you're dealing with Service Bus, you just add this to the using clause at the top, using azure.messaging.servicebus. So those are your prerequisites. The next thing isn't really a prerequisite, but it's like common code. So anytime you're working with Service Bus, you have to create this thing called a Service Bus client. Whether you're sending messages, or receiving messages, or setting up a receiver, whatever you're doing, you need a Service Bus client. And this functions a little bit like your SQL connection if you're doing SQL. So here is an example of what this might look like in a production environment using default Azure credentials and setting some Service Bus client options. So this is high performance AMPQ web sockets, and creating the client here. Service Bus client is new, calling the constructor with your namespace, your credentials, and your options. And notice that the namespace has its test bus namespace .servicebus.windows.net. You have to tack that on. So this is really great and it's secure. And I'm not going to go into what default Azure Credentials does, but it basically does a fall through. You know, I'm not going to go in detail, but if you're using a couple different authentication methods, like maybe you've got MFA installed with Microsoft Entra, but there's other fallbacks you can use, it'll go through and authenticate, and then you can get into your Service Bus client. So that's great, but it's not going to work very well for this demo or for R&D. So there is another way you can do this, and that's with a connection string. And this is a lot like making a SQL Server connection, where you simply create the client passing in the connection string in the constructor. So these connection strings are very long and they contain some encryption keys. And so I'm not going to show you mine, but you can get them a couple of ways. If you go into the portal, there's some clicks you can do to find it. But here is a little command through the CLI, which should enumerate all of your keys. So there's a couple ways to fish the connection string out. And then I'm just storing it in app settings. Okay, so either way, you're going to make a Service Bus client. So those are the prerequisites. You get your namespace, your queue, you install the NuGet package, and you write some code that's going to give you a client whenever you need it. Okay, so now we are ready to send and receive some messages. And by the way, I'll just say, like, everyone has their camera off, so I can't see anyone's faces. If you want to turn your camera on and smile at me, that's fine, and I'll notice if you have a question or if you look confused. It's up to you all. And if you want to interrupt me, you can, and I will have time at the end for questions. But we're getting into the heart of it now, and I just wanted to check in and make sure everyone was okay. So sounds like everyone is. So we're going to now send and receive messages. So here is some very simple C#. Look, we actually get to look at C# to send a message. So first step, create our client with a connection string. And here's the name of the queue we're going to address. And then we create a Service Bus sender by calling client.createSender with the queue name. That's the simplest way to do this. Then we create a message, which has a constructor that takes a string. So here's my first message. And then we call send message async, which is an awaitable, right? So we await it. All of this would be running inside an async method. And once you send message async, then if you go back to the Azure portal, look, you'll see it. Your message count will be 1 and you'll have an active message. So there you go, sending a very simple single message into the queue.
I have a
Now,
question.
yes, sir.
In that thing where I'm creating the receiver and then I'm sending the message, would I do that every time, like in my controller action? Or would I do that in my constructor and kind of keep that sender as a singleton throughout my application? What's the best practice there?
That's a fantastic question. We're going to work towards it. There's a section later in the talk called receiver patterns, like how you would build a receiver. So on the sender side, it probably is on demand, right? Something happens and you're like, okay, time to send a message. And you could just do this. You could, just depending on what your app was, you probably would instantiate the client on the fly, instantiate the sender on the fly, and just send it and be done. It's very low overhead to do that. There's no real advantage to keeping like a static reference sitting around to a client or a sender that multiple threads would have to share. So on the sender side, I do exactly what you said, which is, oh, look, I got to the point where we need to pass the message to the next queue, and I just do this, boom, and it goes. For the receiver, there's a lot more to it, and we're going to spend quite a bit of time talking about that. So great, great question. I usually will wrap this in some method like send the message, right, to hide it away from the rest of the app. But that's usually what it looks like. So here is the other side. So this is the receiver. And we create our client, the Service Bus client. Here's the queue. And now, shocker, we're creating a Service Bus receiver with client.createReceiver. And then Service Bus received message equals receiver dot receive message async. So the first thing you're going to notice is the type of what you get back is not exactly the same. You don't get back a Service Bus message, which is what you sent. You get back a Service Bus received message. And we'll look at that. We'll see what the difference is, but just remember it's a different type. And then there's this last thing, which might be surprising to you, and we're going to talk about it a lot, which is if we got a message, we have to complete it. So we call complete message async. I'm not going to explain it now. We'll come back to it. So there's your simple receiver. And again, Rob, this is not what you would see in production code, kind of just this as an island. We'll come to building a real receiver app in a sec. So looking on the portal, you would then see like, oh, look, there's my message sent and there's my message received. The portal's got really cool tools for monitoring your queues and looking at queue depth and seeing pretty graphs. So really cool stuff there. So that's your basic send and receive. Now, one question you might have is, well, which message did I get? Like, let's say the sender had sent 3 messages and then I received one. So a queue is a first in, first out data structure, right? FIFO. So if you send 3 messages and somebody receives one, they're going to get the first one. The first one in is the first one out. So just keep that in mind, right? Queues are FIFO. It's pretty straightforward, but sometimes people do have a question about that. The other thing to be aware of, so you probably heard the term pub sub, right? Which means either publisher subscriber or publish subscribe. And this is where you have a single sender, but multiple receivers. So Azure Service Bus supports that kind of pattern. They call it topics and subscriptions. So when you create a topic, it's just the same as creating a queue. You go, the CLI command is almost identical, except it's topic create. And when you create the topic, you can then connect to it with a Service Bus sender, same way using the topic name and do a send. It's identical code. But what happens is a single send actually puts a message in every subscriber. Okay, so there'll be different, you set up the subscriptions, you set up a single topic, you configure multiple subscriptions, and when you send a message, it publishes out. And when they receive the message. Okay, let's say you've sent a few messages, 2 messages. When subscription 1 receives it, they get theirs. It has no impact on anyone else. So each subscriber gets to manage their own queue. Now, I want to go back 1 slide and show you something. Do you notice? So you've got your queues and your topics. And do you notice here that on the queue, on that earlier slide, it had message count, active message count, dead letter message count. And here on the topic, we don't have those because the topic isn't really a queue. No messages sit inside the topic. It's kind of this facade, right? You send to the topic, but then each subscription gets the message. So it's kind of just a convenience, really. And then if you look at a subscription, oh, look, there it is, message count, active message count, etc. So when you send to a topic, it really just goes to each subscription. So that's the basic send and receive pattern with FIFO processing and the ability to pub sub if you want to. All right, so those were the basics, how you send a message, how you receive a message. What is in these messages? So that's my next question is like, what are we even sending? We know that at Duran's Pharmacy, they write out a little ticket with your order and they stick it on there. So what kinds of things are you going to send? And in the way I think about this, I really think there are 2 kinds of messages that you might want to send. Now, I distinguish them as heavy versus light. These are Matthew terms. You're not going to go out and see these in any publication or somebody else's talk, I think. This is just a Matthewism, heavy versus light. Sometimes I've heard people talk about stateful versus stateless. So let's talk about a heavy message first. My definition of a heavy message is it contains everything that the receiver needs to take action. It's fully self-contained. They don't have to go get something someplace else. So let's think about a real world example. Let's say you work for a sales company, right? You do quotes. And now let's say it's 30 years ago, right? Let's go back in time. So when you submit a quote, there's this approval process. So you actually, you're on Word 95 or whatever, you type out your quote, and then you print it, and you place the physical document in an inbox of your approver, your boss, with a little yellow Post-it note on it that says, please review this, okay? So that's the message, right? The message is actually the bid with the little ticket that says, please review. And then when your boss gets around to it, they pull the thing out of the box, and he or she reads it and, approves it or denies it. So as you can see, right, it's fully self-contained, right? The reviewer in this case doesn't have to go fish something out of a file cabinet or wander down the hall and find you, right? You've given them a fully complete, heavy message that is actionable. Now let's hop forward 30 years and say you're still working the same job. But the way it would happen now is when you compose this, you're probably using a CRM of some kind of bid management software. And as you work the quote and you click save or it auto saves, it's putting stuff in some repository, right? There's a database and it kind of saves. And when you are ready to submit this, you click a button and you say, okay, submit. And it sends a message to your reviewer's Slack or whatever collaboration channel you're using, right? And they get a message saying, hey, you've got something to review. And then when they receive the message and they go to review it, they actually retrieve the bid itself from the database, right? They have to do this additional step. So the sender and the receiver are kind of interestingly coupled together by this repository or this database. So in this case, this is a light message. It doesn't contain very much, right? It's just like the date and the ID and here's what you need to do, right? So this is lovely, and it supports a very lightweight kind of event-based programming pattern where you say, oh, an event happened, and if somebody cares about it, they can take action. So just before I move on, I've used them both, right? There's no right or wrong. I've actually used them both in the same application, where at one level it made sense just to like send a very lightweight event, and then the next level actually sent a full document to the next receiver. There's just pros and cons, and you got to think it through. So, the really the upside of the heavy message is there is no sort of external dependency. There's no implicit coupling. It's just very complete, and so the sender can be just done with it. The downside is it's stateful, and so if the data changes, now all of a sudden this message has like a stale copy of the data, and you kind of have a problem of reconciling that or getting them out of order. Lightweight messages, I think, is probably what most people think of with eventing, and it's very simple, but it can inadvertently create some coupling behind the scenes because of the shared repository. So it's up to you. Just think it through. Either way, a very common way to actually send the content is to use JSON serialized content. And this is real familiar to a lot of us. You create a data class of some kind. So here's a bid class. And when you go to send it, we just instantiate a bid and we create a message. And there's sort of two very nice syntaxes here. One is to call JSON serializer.serialize, which takes your object and makes it a string for this constructor. Or if you use the body property setter like this, that actually implements JSON serialization automatically for you. So this is really cool. The body of a message is actually binary content. So it gets it has to get binaryified. Both of these will do it for you kind of on the fly, which is very cool. Now, you can also do binary content. So let's say you really wanted the whole PDF, or that Word doc or that PDF, you wanted the whole thing. So you could, again, read all the bytes into a byte array, and then simply your subject is that bid, right? So this now becomes like the post-it note. And then here's the body, which is the actual PDF, right? You can jam a lot of data in. Now, the different tiers for Azure Service Bus have different limits, but I believe if you're using the premium tier and AMPQ WebSockets, it's 100 megs per message. You can make gigantic messages if you want to. The last thing to think about with your message bodies, with your content, are correlation IDs. So I don't know if you've heard of this term, but basically a correlation ID is an ID that persists across all the layers of a microservice system, a distributed system. And it's up to the very first player, the first link in the chain, to create it. And then it's up to everybody to pass it on down the chain as you go. And what correlation IDs do is they allow you to log the journey across a distributed system. So imagine that e-commerce example where you've got an order intake processor and a financial system and a pick, pack, ship system, inventory adjustment, email notifications, all this stuff. Those are all separate services. And as long as you're using correlation IDs, it's really easy to see, okay, here's the journey of one person's order and all the places it went. And this is so important that Microsoft has enshrined it with a top-level property on Service Bus Message. So if you don't get much out of this talk, if you come away from it thinking, hey, I ought to use correlation IDs, I think you've learned something really valuable. I use them all the time when I'm doing distributed systems. And, we just assign GUIDs, and that works really well. And there are even logging tools that will use that then and help give you the distributed log across your whole system. Okay, so we have done the basics. We've talked about the content. Now we have to get into receiver modes and options. So we're about halfway through the talk, and we are getting to probably some of the most important and a little challenging content. So take a breath, and here we go. So the first thing you need to keep in mind is this concept of receive timeout. So what happens when you call receiver dot receive message async, and there's no message in the queue. What happens? Well, by default, it's going to wait 60 seconds, and then it's going to return null, a null message. And in my experience, 60 seconds is a very long time for your app to be awaiting. So you can just configure it. So you create a time span. So here you have a message receiver that only waits 5 seconds, right? And then you always check to see if you got something back and then process it. So that's a very important detail to think about is your receive timeout. The next thing we're going to talk about is receiver modes. And there are two, receive and delete and peak lock. So peak lock is the default, and it's what most people are using. But I'm going to start with receive and delete because it is just much simpler. It's very easy to understand. So let's do receive and delete first. And the way you configure it is you can make some service bus receiver options and set your receive mode to receive and delete. And then when you create your receiver, you give it the queue name and the options, and then you just go ahead and receive the message. So what happens here is as soon as you get a message, it is permanently deleted from the server. It's gone. Right? There's no retry. You just got it and it's deleted. This is pure MSMQ style queuing, where you receive and then it deletes it from the queue and the next message comes to the front. So this is intuitive and easy. And in many apps, this really is, it simplifies things a lot. So you should know about this, right? Receive and delete. It's very straightforward. However, as I said, the default is peak locks. And this is where we're going to really take some time to understand what's going on. So what is a peak lock? So here's what happens. When you receive the message, you call await receiver.receive message async, and you get the message. On the server, it starts a timer going. So it knows that somebody got a copy of the message. It marks the message as, okay, it's peak locked. It puts a peak lock on it. And that kind of hides it from the queue. So if another receiver tries to receive, it'll get the next message, right? Your message is locked. No one else can get it. And that timer goes tick, 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 tick. And you, the client, have to take some kind of action before that timeout expires. So you have to do something to tell the server, okay, now it's safe to delete it. Or put it back. I want to try again later. Right? You have to do some completion action on the message. And if you don't do your completion action before the timeout expires, it does one for you, which you'll see, it abandons it, which puts it back in the queue. So that's how a peak lock works. It starts a timer, and you have that amount of time to complete the message or to do a completion action. So what are your choices? What are the peak lock completion actions? The first one is you can complete the message by calling complete message async, which you saw, right? I said, oh, I'm going to explain this later. Well, here we are. So the message is removed from the queue, and this is used for normal successful message processing. So with peak lock, your normal pattern is receive message async, and then do what you need to do. And if that worked, complete it, and then move on to the next message. Your next option is called dead letter. So you call dead letter message async. And in this case, the message is removed from the queue, and it's placed in a special dead letter queue. And you saw the count earlier in the screenshot. So this is generally used when the message is not processable. You're like, that's bad, can't do it. Now it is, so for example, we'll talk about poison messages. You may have heard that term. Poison messages need to go to the dead letter queue. So it's possible to replay your dead letter queue using various tools on the portal and the Azure CLI. So they're not gone forever, and you can put them back in the queue and rerun them. if you want to. Then you have abandon, and this is weirdly named. What it means is the client is abandoning it, not the server. So you call abandon message async, and here's what happens. The message is unlocked and its retry counter is incremented. So basically, it reappears in the queue. Right? You had it locked, you abandoned it, it's back in the queue. It's right there in the queue. And the next time somebody calls receive, they're going to get it again. So this is used when the message might be able to be processed in the future. So you want to put it back in the queue and retry it. Now, the number of allowed retries is configurable. And when the message hits this maximum of allowed deliveries, the next abandon actually dead letters it. So this is also what your timeout does. So if you don't take action in the timeout, it abandons and the message is unlocked and your counter is incremented. The default, we're going to talk about the default, but it's 10 retries by default, and then it dead letters. There's one other option called defer message async. The message technically stays in the main queue, but it's marked as deferred. And in order to receive it, you have to use these special methods and you have to save a sequence number. And I don't use this, okay? It creates complex message ordering and access issues. I would just say it should be used with caution, right? I haven't found a use case for it yet. The three main ones that you see are complete, dead letter, and abandon. So here are a couple of settings, screenshots from the portal, and you can see we have our message lock duration. So the default peak lock is 1 minute, and you can change it. It can go down to 5 seconds, I think, and all the way up to, I can't remember, 20 minutes or something. It's not huge, but you can adjust it. And here's that max delivery count, right? This is the retry counter. And by default, it's 10. It's going to retry 10 times, but you can change that as well. So that's peak locks. And it's a lot to digest and a lot to think about. And it's something that really, you probably need to write some code and test it to really get a feel for what's going on. And at the end, I have a little live demo and I have a code sample that we can distribute as well. So you can get in there and play with it. Okay, so now we're getting to Rob's question, which is our receiver patterns, because you are absolutely right? You're not going to want to just like, oh, hey, there might be a message. Let me create a receiver and see if there is one, right? You're probably going to have some kind of long running process which is sitting there waiting for messages, right? Its job is to monitor a queue, and it's monitoring the queue. And oh, look, a message came in. I better do something. So one way to do that is with a message pump. This is a very simple standard pattern, right? This is how Windows is built. Lots of systems use event pumps or message pumps. So here is a simple implementation of a message pump. And one thing you'll notice is that I'm passing in a cancellation token. This is implementing what's called the cooperative cancellation pattern, which is where the server can gracefully tell a client, in this case, or some long-running thing, okay, stop, please, gracefully instead of just, killing it. And I have a YouTube video that actually goes into the whole cooperative cancellation pattern, if that's something that you want to learn more about. So how does this message pump thing work? So we get our queue name, we create our client, we create a receiver, and we set up our time span, and then it just logs. We're going to start this, and here's here's a long running loop, not infinite, but while not cancellation token dot is cancellation requested. So basically, until I get the cancel, just keep looping. So this is a long running message pump loop. And then inside the loop, we try to get a message here. So we await receive message async. And if our polling interval was 5 seconds, it'll await there for 5 seconds. And then if no message came, this will be null. And then it just loops again and it calls again. So this actually creates a natural polling interval without having to put in any kind of sleeps or waits of any kind. If you did get a message, then it calls some other function called process message, and then it completes it. And the other thing you'll notice is it's doing a try catch, which is really important. And in this particular case, we're just abandoning the message, putting it back in the queue to retry it. So there's a fully realized message pump. And again, in my sample code, in the project I can send you, it's there and you can play with it. So that's one way to build a long-running message receiver, and you have a lot of control. A little nuance here is that you can work with batches, whether you're doing it, no matter how you're doing the receiver, you can pull more than one message. So the way you do that is you call await receiver.receive messages async, passing in a batch size and the timeout. And that, instead of giving you back a single message, it gives you an I read-only list of service bus received messages. So that will return a collection. It might be an empty collection. It might have count of 0, but it will give you this I read-only list. And then you can loop them for each message and messages, process it, and maybe complete it or try catch, abandon it, whatever you need to do. So the batch size is kind of interesting. I've got batch size of 3 here. So let's say there were 7 messages in the queue. The first call to this would give you the first 3. Then the next call would give you the next 3. The third call would give you the remainder, 1. And then the next call would give you none. So this is just the maximum amount you're going to get. You're not guaranteed to get 3 messages, but you won't get more than 3. So you can build a message pump that is batch-based, but there's a gotcha on this. I thought I had a slide for it, but I don't. But the gotcha is when you call receiver.receive messages async, the peak lock timer, if you're using peak locks, the peak lock timer starts for every message. So if you pull 10 messages and your message processor, takes a little time, you probably will finish them. But then let's say something happens and your processor is slow, a dependent service is laggy, you can get messages timing out, right? The peak locks can time out. So this is a cool, prefetch kind of way of doing things, but you do have to pay attention to your peak lock timeouts if you're combining this with peak locks. All right, and then the last receiver pattern is the easiest one to use. And if you go on learn.microsoft.com, this is what they're going to show you as the first demo because it's so lovely and easy. And this is a helper class called Service Bus Processor, which actually wraps one or more service bus receivers. So it actually implements all that message pump and cooperative cancellation code, all of that for you in a very nice way. So the way you do this is you create a service bus processor by calling client.createProcessor, and then you wire up 2 event handlers, an on message, process message async, and process error async. And here we have our 2 message handlers where we're going to either handle the message or handle an error. And one neat thing about this is by default, it does autocomplete. So if you're using peak locks, on message async, we'll call we'll call receiver.complete message async for you right here. And the error one will call receiver abandon message async for you right here as it exits this. So this is very, very nice and elegant and hides away a lot of the complexity. So you've got a few choices. And again, I've used them all. All right, so the last thing we need to talk about in our last 10 minutes or so is errors and fault tolerance. Because, if we stop the presentation right now, you could probably go out there and write some basic service bus code and it would work, but it might not be robust, right? You got to think through some of the real world things. And what I'm going to share with you now, these are things that I've literally actually run into. These are not theoretical problems, and you want to be prepared. And the easiest way to talk about these problems is to have a real kind of, hypothetical, but real world application in mind. So here's our little sample app. Imagine you've got a weather reporting app, and you've got these weather stations out there in the world all recording data. And the way that they send their data to you is by sending little weather reports to a weather report queue. And then your receiver is this report processor, which, you've got lots of senders and a single receiver. This is a very common pattern. And what it needs to do is it needs to basically kind of parse and validate the input and then save it down to a SQL database. So all these reports get stuck in a SQL database, and then, maybe there's other stuff that publishes reports, but that's the basic receiver. So here is a little code, and imagine we are using that service bus processor helper class. And this is our on message received event handler. So the first thing we can do is we can say, give me the args, which is the process message event args, dot message, which is the service bus received message, dot body dot toString. So that should be the weather report JSON. And then we'll deserialize it, calling JSON serialize dot deserialize. Now, what happens if this is not valid JSON? You guys know, right? It throws. This throws an exception. And so if this message here is not valid JSON, maybe it was just an accident, or maybe it's malicious. Maybe somebody out there is sending intentionally broken messages. Those are poison messages. And what that means is it will never work. Doesn't matter how many times you retry it, it's simply going to fail. So if we don't do anything, if we simply have this on message error handler, it's going to log the error. And then what's going to happen? We got to think it through. So let's say we're using all of our defaults, which is 10 retries and peak lock. So it's going to abandon the message, which will put it back in the queue. And then the receiver is going to get it again. And it's going to try to deserialize it. And it's going to fail. And this is going to run. And it's going to abandon it again and again and again. And it's going to churn 10 times. And then it's going to end up in the dead letter queue. So the problem with Azure Service Bus and Poison Messages is it has kind of like a built-in DDoS amplifier with this retry, okay? So you need to cut that, and you need to just identify poison messages and dead letter them straight away. Just get them out. So here is this particular poison message solved. We just do try with all that same code, catch JSON exception, and then we're going to dead letter it. Now that's just one example, right? This was our JSON serialization, but you could, implement this with a whole cascade of exception, typed exception handlers if you wanted to. The work you have to do is you need to understand what are the kinds of things that are unrecoverable, right? What could fail in a way that it makes no sense to retry it, identify those, and just dead letter them. Get them out of your way. So the next thing to consider are what I will call transient error conditions. So in our little weather reporting data, we deserialize the message. And then let's say we do something like this. We create a SQL connection, we open it, and we write it to SQL. So what happens here if SQL is down? So usually it takes about a minute till you find out if you're using the default, and then it throws an exception. And if you don't do anything different, that exception will cause your message to be abandoned. It'll try again real fast, 10 times in a row. There might be a minute between them because this has a timeout, but it'll go 10 times, and then it'll end up in the dead letter queue. And then the system will move on to the next message, and the same thing will happen. And I have literally seen where people will come in the next morning and there's 58,000 or 580,000 messages sitting in the dead letter queue because this thing just became, it churned through all these abandons and retries, and it just dead lettered them all. And they were all valid, right? They all could have been processed. So what do you do about this one, right? This is very different than the poison letter. So the way to solve transient error conditions is, again, to identify them and then stand off and try later. You need to stop the message queue until it's safe. It's almost like, right, there's lightning around, clear the public swimming pool. Nobody gets to swim while there's lightning. And once you haven't heard thunder for 10 minutes, then the lifeguards let you back in the pool. Same thing. So here we could catch the SQL exception, which we know is going to be transient. So we abandon the one, right? This was our canary in the coal mine. This told us there was a problem. So we can abandon that message. And then I'm calling this function, which I called pause the processor. So we do processor dot stop processing async, and then we drop into this monitor loop, which says, okay, test the SQL connection. And if it worked, then restart the processor. Otherwise, wait a minute, and then go back and test the SQL connection, right? And we'll just sit here and we'll wait until SQL comes back. And then we can go back to processing. So that's the basic technique, is to stand off and retry. And again, you have to know your system. Like, what are the dependent services? Are there REST APIs? Are there queues? Other Azure services? What are you dependent upon that could be temporarily unavailable? How do you identify that? And what's the proper kind of retry methodology? So those are sort of the two key things to look out for: poison messages and transient error conditions, and handle them separately. All right, time to wrap up here. So, when we started on this journey with our visit over to the vending machine and our visit down to Duran Central Pharmacy, it seemed pretty simple, right? We want to send messages to queues and we want to receive them. And it is conceptually, this is very simple and really powerful. But when it comes to Azure Service Bus, you've actually got a lot of choices to make. You have to choose. Am I just using simple queues, or am I pub subbing with topics and subscriptions? Do I want to pack a lot of data into these heavy self-contained messages, or do I want to go more event-based and use light messages? Do I want to use the default peak lock with all the power of retries? Or do I want to go with the simplicity of receive and delete and kind of handle errors in my own way by making secondary queues and other things? Do I want to use the service bus processor, which gives me so much? Or do I have a real reason that I need to kind of hand roll my own message pump? Is it simplest and best just to do one message at a time? Or do I really have a use case for doing batches or prefetch? You'll notice that some of the peak lock patterns can actually get messages out of order, right? If you've got multiple receivers. So there are things that can get you out of strict FIFO, and does it matter to you or not? Is how important is message ordering? So are you going to enforce that with the choices you make or not? And when you're actually processing them, have you done the work to figure out how to abandon and retry failed messages or immediately dead letter them and understand the real error conditions? So there's some thinking, right, to make one that will really hold up in the real world. Okay, so the next slide is the last one. I actually have a software demo if we want to. Let me stop sharing. And if you want to, you can turn your cameras on. So at this point, Rob, we can just go right into questions and have a little conversation. If people would like me to show my little software demo, it only takes 5 minutes. I can show it. And so it's up to you where you want to go. We are at the top of the hour. It's 7. There's Caleb. I think everyone died. Everyone slipped into a coma or slipped off to the bar. I did it. Success.
You made him go get food.
Yeah, I made you all hungry. I'm sorry.
Okay, so we have one person saying go for demo. I was thinking the same thing, but I was hoping to get some feedback from the group. So I think that's 2 of us. So 100% of everyone who has responded says demo.
All right. I
And
do
me
hope
too.
some
I
of
think
you
a
will
demo would be
talk.
great.
Okay, we've got a thumbs up there from Kelly. I mean, I believe that Kelly and Blake and Brent, I believe you're real people. I do, on faith here. So hopefully, I mean, I would love, I love the interaction part of this. Actually, I would have flown to Phoenix. I would have flown to Salt Lake City, right? I actually much prefer to do all this in person, just because the actual human interaction is so good. But anyway, so don't be shy if you want to. All right, let me share my screen again, and let me stop the uh, the presentation. How do I do that? Come on, give me just a sec. And all right, presentation's gone. Visual Studio is here. Can everyone see Visual Studio? Yep. All right. So F5 to run this little guy, and it's a console app. So here we go. So welcome to the Service Bus demo program. Here are your menu options. We've got some menu options. So why don't we start with menu option number 1? Let's just send a simple message. We send it, and look, it tells us a simple message was sent. And now let's do option 3 to receive that message back out of the queue. So we'll do number 3, and a simple message was received. So again, I'm showing you how the little app works, and then when you get the source code, you can kind of see what was happening. So now let's send a weather report message, which is a little more complicated, does some JSON serialization. And why don't we also now send a simple message? And how about another weather report? And now I'm going to receive a batch of messages, right? I'm going to do some batch processing. So we'll do 5. And you can see that it received a weather report, right? And a simple message. And so that's all I had in my batch, I guess, just 2. So we've done send simple, we've done receive 1, we've done send a weather report, we did a receiver. There's also receive and delete. I don't have to show that to you here. I have a little loop which will send several messages. So that's kind of a fun thing. And it just sends, I think, 5 messages. And then you can start and stop a message pump, and you can start and stop a service bus receiver. So we've got 5 messages in the queue. So if I start the message pump, it's going to receive them all, right? I just got them, 1, 2, 3, 4, 5. And if I now send another batch of messages, right, we can do 5 and do 5 again, maybe. Let's see what it'll do. Oh, did it stall? What happened here? What is it doing? 0 messages. Oh, I think I'm calling the wrong one. Oh, 6. Wrong item. Okay, so it's now you can see it's looping and sending 5 messages. Meanwhile, the message pump is picking them up as they're being sent. And we can go ahead and stop the message pump if we want. So that'll be 8. Message pump is stopped. And now let's send a couple weather reports. So, and last we can start a service bus processor. So this is the event-based one, and there it pulled all those weather reports, and you can see they all have individual correlation IDs. And again, if I send it more messages, the service bus processor is receiving them pretty much as they're being sent. So that's the code demo. It's just, again, simple thing to kind of show you what's going on, and it's implemented here. If you haven't used pattern matching switch statements yet in C#, you should check it out. It's a very cool way, and I'm using it here to actually as a function dispatcher, using pattern matching switch for the input. So the sender looks a lot like the code I showed you, right? We're going to get a client. We're going to configure a queue. We'll instantiate a sender, and we'll send the message. Await send message async. And here's sending the more complex message with the weather report. Okay. And here's your receiver code. The basic receive a single message where it makes the client, gets the queue, makes the receiver, does a receive timeout, a receive with a timeout of 5 seconds. If it got a message, it processes it, which just logs it to the console and completes it. And here's a little batch receiver where it's pulling 3 at a time. That's my batch size. And then here is doing it in receive and delete mode with the service bus options, the receiver options. Here's a message pump. And then the processor just has where we start the processor, it creates it and wires up the event handler and starts it, stopping it. The only thing interesting here is we are disposing of it, right? Because this is keeping a static reference to an iDisposable. So it's not inside a using clause or using statement. So we have to manually dispose of it. And here's what it does on message, and here's what it does on error. So it's a very simple little code project. And Caleb, Bob, why don't at the end, you guys let me know. I have it as a zip file, and I'm not sure. I don't have it on Git anywhere, but maybe we can. There's a way to distribute the file right now, if that sounds reasonable. I probably should put it on Git. I just haven't.
Yeah, that would be
all
my
right,
preference.
Brent. Thank you so much.
GitHub project, that would be perfect.
Yeah. Say again, Rob?
That would be my preference. If you have a GitHub URL, then we don't have to worry about where do we host the zip file and am I responsible for the zip file and yeah.
Yeah, so some groups have a way to do that and distribute stuff, but let me I just need to do the work of actually publishing it, figuring out which GitHub repository this kind of stuff should go in, and then publishing it. And then I can send a message back out to you all and you can distribute the link, but I don't have it tonight. So
that sounds awesome. I'll wire up my message receiver and wait anxiously for the message to arrive.
There you go. All right. So any questions, discussion points?
I have one.
Yeah.
In Kafka, when I have multiple subscribers, they're all pointers against the same queue. But the way you were describing it, it sounds like in Service Bus, that's not the case. And rather the message processor, if it's going to process it to 3 different receivers, it pushes 3 different messages. Is that right?
Okay.
Does each consumer get its own queue?
So each consumer gets its own subscription, right? So you subscribe when you're going to receive. Yeah, you in the Azure portal, you have to configure the subscriptions. They are named, right? It's not like dynamic where anybody can just subscribe to it. You actually say, I've got subscriber 1, subscriber 2, subscriber 3, and they function like queues. Now, in terms of the physical storage or whatever, I'm sure that, it may not be that, it probably saves a single copy of the message and then sticks it there on demand and sends it out just to optimize storage, in case you have big messages. But that's sort of an implementation detail. But the reality is it's not like a broadcast. Okay, so by analogy, think about like listening to the radio, right? It's the signals out there, anyone can tune into it. That's a broadcast, or like UDP or something, right? So it's not like that. It's a little more like cable where you have to subscribe, and then if you subscribe, you get the content. Okay.
Now we'll let Vivek go because he had his hand raised at the very beginning. Yeah. So I'll let him answer. And then I have more questions because of your statement.
Is there a limitation on the number of messages that can a queue hold?
So I believe the default subscription plan does have a message limit, which is really more of a billing fact. Like they will only let you transit a certain number of messages through, but it's huge. It's like hundreds of millions or something. So there's really not like a hit to your Azure bill for storage. It's a compute service. You get billed for compute, not for storage. There is, on any given queue or topic, you do have Let me just, I think I have a screenshot I can show, or let me just refer. Yeah, so the default is 1 gig is the maximum size. And there are other properties like you can set an expiration time. Where messages, if they sit in the queue too long, will automatically expire and dead letter.
So
And
that
there's
is the time to live. Is that the
uh,
time?
yeah, message time to live is actually, oh, I'd have to look that one up. Okay, I actually haven't used that. It's more the max size, I think, which controls how much stuff you can have in the queue, and it's based on the size of your messages. So yeah, those are good
Okay.
questions, and there are a lot of knobs and options in Azure Service Bus, and like all Azure things, and I haven't used them all. So good question.
And does like the architecture dictates what should be the size of the queue?
You mean your use case?
Yeah, like if you have you have subscribers, right? So the rate at which they are subscribing and at what time like subscribing, does that dictate how much will be the length of the queue?
Right. I mean, I guess it really is up to your use case. So on the last one I did in the real world, the it was microservices, and one of our key performance metrics was queue depth, and we actually had an alert that went out if queue depth got past 50.
Okay.
So what that meant is that it was falling behind, right? So there's a thing on the input that's responding to events out in some external system, and it's taking these events and it's queuing them for processing, right? So it's this like collector kind of thing, right? Its job is just to collect the events, make messages, and put them on the queue for processing. Then that processor had some pretty heavy lifting to do because it was integrating with other systems, a couple other systems, one of which in particular could be very slow, right? The like REST API return round trips in the seconds and maybe needing to do dozens of them. So in certain situations, it could take up to a minute to process each message. So for us, if that second step, if the queue depth got past 50, what that meant is it's getting backed up, right? It's falling behind, and we're out of balance between what's coming in and what's going out, right? And the tub is going to overflow at some point. So what we actually did, Vivek, is we parallelized the receiver. So we used, in this case, we were using Kata and Azure Kubernetes, AKS, and this receiver was in a little, console app, which was hosted in Docker, basically. And so we configured Kata to look at the queue depth, and it could spawn a second one. When queue depth got to a certain point, we get 2 receivers, and then we could get 3. So it could scale up the receivers to deal with a flood of messages or kind of slow service on the backside. It doesn't happen very often, but when we do get this backlogging problem, that's how we handled it. So but that's a microservices thing where they're kind of in a chain. It's not really pub sub, right? The subscribers have a job to do. They have to do it, and they have to have the power to handle the throughput. Does that make sense?
Yeah, makes sense. So
Okay.
the horizontal scaling of the pods here, right? So
Yeah.
was that configured in Azure portal? Like you can do that?
Oh, well, there's lots of ways to do that. The tool we use is called Keda, Keda, and it kind of sits on top of. It's not a Microsoft tool, right? But actually Microsoft uses it. Azure Functions is implemented using Keda internally, but for its scaling. So you can do it yourself. It kind of just depends on how your code is deployed. Um, let me just Keda is when you're using Azure Kubernetes service. So if your thing was deployed in Docker and AKS, you could then use Keda to handle your scaling declaratively. You can also do it directly if you know how to use Kubernetes, which is a heavier lift. Another option you have is you can create Azure functions. I didn't show this; it's a whole other thing. An Azure function which is bound to a queue, and so the Azure function itself will get instantiated and run as a message receiver when a message comes into a queue, and then through the portal you can configure the horizontal scale of your function. Like, how many instances of my function do I want? And then all of the scaling is just done for you, right? You don't have to mess with any of that. So there are other, there's other ways to horizontally scale. You can even multi-thread your app if you wanted to, right? So you could, for example, treat each incoming request as a task, put them in a task list, and then await all, right? And so you could like await 100 of these things in parallel, if that made sense.
Yeah.
So you've got options, Vivek, and it just kind of depends on how you're planning to deploy your app and how you want to control the horizontal scaling. It's complicated, but you have a lot of choices.
Thank you.
Yeah, great questions. Thanks.
Yeah.
Caleb,
So if
you want to follow up, yeah?
yes, and I don't know that I remember the exact way I was going to word it, but basically I was going to talk about or mention there's a distinction between the topics and the queues, right? So the queues, you have those consumers and there is a message, and once that message is gone, it's gone. Whereas the topic, all of the subscribers on the topic, they can receive a message off of the topic, and it doesn't actually delete it from the queue.
No, each subscription functions as its own queue. And when you write something to pull from the subscription, it looks exactly like the receiver. You can use a message pump. You can use both receiver modes, like every single choice that I went through. You could have one receiver using peak locks and another using receive and delete. Literally, the Azure, subscriptions, you create a single topic and then you create multiple subscriptions. They are just queues. They function exactly like queues. It's just that you don't have to send to each one. I believe you could implement the same thing just by you saying, oh, well, I'm just going to set up 10 queues. And when a message comes in, I'm going to send it to each 10, right? It's literally just a convenience. So you only send once. As far as I can tell, their subscriptions just are queues that have a slightly different way that the sender interacts with them. But the receivers,
I like to think
it's the
of
same.
it is the topic is like the drawer in the filing cabinet. And inside that drawer, I have various subscriptions. I have various folders. And so each subscription is a folder. And so, if I'm going to distribute a message, I may open multiple folders and stick a message into it. But I've opened the correct drawer to be able to get into that topic. So, topics then are kind of more organizational structures and less about distribution.
Yeah, I mean, to me, like the metaphor I think of is if I set up a queue, let's go to that inbox problem, right? Where you've got the wire tray sitting on somebody's desk, right? There's a queue, your inbox. With a queue system, you just put the message in the queue and you're done. With the topics and subscriptions, there's like 3 people who have 3 desks and they have a wire basket on each desk. And you've hired an assistant, right? And his name is Mr. Topic. And you hand him the message and he photocopies it and puts one in each basket, or something like that. It really, to me, the topic isn't a thing. It has no storage. It has no counts. You can't replay it. There's nothing in the topic. You go look at the topic and all it is a router to the subscriptions. You look at the subscription and it's got configurable size and it's got queues and it's got a dead letter box and it's got abandoned counts. So, I may be wrong, but it looks to me like it really isn't Kafka at all, right? It's this kind of thing Microsoft did to make it seem like PubSub, but it's really just a slight convenience on having lots of queues. If I'm wrong, if you guys are like, wait, this doesn't sound right, and you go do some research and you're like, that guy was wrong, please tell me, right? I don't claim to be like the expert on all of this, but this has been my experience.
I think I may have missed
So-
some of the points at which you were talking about topics versus subscriptions, or I should say, versus the queue, like raw native queue functionality. So when you're talking about subscriptions, you're not talking about someone like subscribing to a queue per se, but more so to a topic. Is that correct? Because I've never had to subscribe to, like, when I just write code, I never have to subscribe to a queue. I just say, hey, I want to listen to this queue. All right, and then I
Right.
get messages.
Yeah. So
But I haven't dealt a lot with the topics. Just I haven't had the
Yeah.
need to in my area. And then
it's simple, Caleb. It really is simpler. Like, I think the line of questioning makes me think you guys have done Kafka, and which is a lot more sophisticated in this respect. Let me hang on one second. All right, I'm going to share my screen real quick.
Okay.
Let me just make sure there's nothing like proprietary, because we are recording this, right?
yes, we are.
Okay.
I mean, although I can edit out stuff if something accidentally shows up.
All right. So look, this is my Azure portal, and here's my test bus namespace. Okay.
Yep.
This is so silly. Hang on. Let me put this over here. All right. So what you can see is I have one queue, my first queue, and I have one topic, my first topic. Okay. So I could send to either. If I made a service bus sender and I gave it my first queue, that's where it would send.
Okay.
And if I made a service bus sender and I gave it my first topic, that's where it would send. And you'll notice that this topic has a single lonely subscription. If I click on it, okay, this is my topic.
Yep.
And
is it the topic or subscription that has event filters? So we can say, hey, I want to limit it to these things, these types of events.
I haven't done anything that sounds like event filters in Azure Service Bus. All right. So here is the topic, and you can see it's got a subscription. And the subscription looks just like a queue. Ding, 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 ding. So now let's make another subscription. Let's just add one.
I like your point. It feels a lot less like Kafka and a lot more like AWS, SNS, and SQS.
Subscription 2. And you see it's got its own retry counter. It's got its own properties, but let's just create it. It's got its own time to automatic dead lettering. So now I've got two of them. All right. Now let me bring back my code. And what we're going to do is we're going to go to our service bus sender. And here's my queue name. So I'm going to stop sharing for just a second because I have to go. Actually, no, let's do it a different way. So what was my topic called? My first topic. That's the name. I was going to go into my app settings and then you would see my connection string and blah, blah, blah. So, all right. So there we go. And now here, I'm going to send to the topic instead of the queue. Wait. Fair enough?
Yep.
Okay, so we're going to run this. And we'll do option 1. Okay, message sent. Stop. We're going to go back to the portal. And we are going to refresh. So both subscriptions have a message now. Okay, my topic, like if I go back one level here, no. my first topic, you can see it's like, okay, yeah, a message was sent to this topic. Okay, but the topic doesn't have a message. They're in the subscriptions. Now, let's go to our receiver. So I've got subscription 1, subscription 2. So here's our receiver. And we're going to just hack this. So again, we'll get rid of this. And we'll say string subscription equals subscription 2. And string topic equals my first topic. And then I'm going to do client create receiver, passing in the topic and the subscription name instead of just a queue. So when you make a receiver to a subscription, you have to specify both. All right, and then we're going to receive it, and let's see what happens. Okay, so we're going to do number 3, receive a single message. Okay, message was received. Now, can you imagine what we're going to see when we refresh this? That went to 0. It's still there. So if you wanted, let's say you would like your own subscription, you have to tell me, hey, Azure administrator, make me a subscription. You can't just go subscribe, right? You can't just sign yourself up. And the rules for your subscription, how you handle it, whether you peak lock or receive or dead letter, and also how I've got it configured on the server side, the max delivery count and message to live, all these settings, it's per subscription. So again, this is why to me, my impression is these are just queues with a friendly topic thing that happens to be publishing the messages into these queues, which happen to be called subscriptions.
And here's the filters that I was mentioning earlier, the add filter at the bottom, where you can choose messages.
I see. So then that's at the subscription level, right? So
yes.
A subscriber is not actually, that term isn't in the code anywhere, right? You have a receiver.
Yep.
Yeah. So there, I haven't played with the message filters. That's kind of cool. So there's a lot here, you know.
Yes.
Did that help? I mean, that was a long detour, but did that help clarify?
No, yes, it was great. It's
all right.
It's obviously been too long, and there's enough detail there. I didn't remember it all, and I appreciate the clarifications.
Yeah, and it isn't Kafka, right? But it is, what it is Azure queues. Like I said at the beginning, it's Azure queues. It's MSMQ brought into the cloud. And I don't know if any of you all have done MSMQ. I mean, I remember I did my first MSMQ app in about, 2006 maybe, or 2008. I don't know, it's been a while. But no, it's a durable technology. It's been around for a long time, and it's really useful. Okay. Let me stop sharing. Great questions, you guys. I love that. That made my evening. We're a little over time. Anyone else have things they want to talk about? Book flights to Albuquerque, go to Durand's. Cool. All right. Thank you very much. I really appreciate your time and attention and the opportunity.